All right, let's set the scene. Imagine it's 3 a.m., you're on call, and then it happens. The absolute worst case scenario. Your entire cloud infrastructure in your primary region, poof, it's just gone. So what now? What's your first move? Is it just sheer panic, or are you calmly reaching for a playbook? And look, this isn't just a made-up exercise. For someone somewhere, this is a very real, very bad Tuesday. The difference between a career-ending outage and, well, a heroic recovery, that's exactly what we're going to talk about today. And there it is, the alert that makes your heart just stop. A major regional outage has been detected. The clock is officially ticking. And right now, that disaster recovery plan you wrote, it's no longer just a document sitting on a shared drive. Nope, it's a live, high-stakes operation.
But here's the thing. We're not panicking, we're executing. See, a real DR strategy isn't about scrambling to react. It's about following a predefined, tested playbook. And that playbook, it's all built around two absolutely fundamental concepts.
First up is your recovery point objective, or RPO. You know, what's really interesting about this is that it's not just a technical term. It forces you to ask a really tough business question. How much data can we afford to lose forever? Are we talking seconds of customer transactions, or is maybe an hour's worth of work okay? Your answer here is going to dictate everything, your tech choices, your architecture, the whole deal. And the other side of that coin is your recovery time objective, or RTO. This one's all about speed. It answers the question, how quickly do we have to be back online? Is it 5 minutes? 4 hours? The business has to be the one to define this, because trust me, a 5-minute RTO comes with a very different price tag and way more complexity than a 4-hour one. Okay, so with our RPO and RTO clearly defined, we know our mission. Now, it's go time. We've got to bring our core application back online piece by piece, starting with the most critical stuff. In our little simulation here, we've got 3 main components: a database, a file share, and a data lake. All right, first up, the absolute heart of the application, our Cloud SQL database. I mean, let's be real, if the database is down, nothing else even matters. This is priority number 1. Our goal is simple: get it back online in our secondary region with as little data loss as humanly possible. So for Cloud SQL, we've got a pretty clear choice to make. We could restore from an automated backup, but that's going to take longer and it means losing more data. The other option? A cross-region read replica. Now here's a super important point. It's not just about speed. While that replica is perfect for a regional failure like this one, a backup is actually your best friend against something like data corruption or a ransomware attack. Why? Because it lets you go back in time to a point before the bad thing happened. But for this outage, the replica is our hero. It brings our RPO and RTO down from hours to literally just minutes. And for a service this critical, that trade-off is a no-brainer. We're using the replica. And the process is surprisingly straightforward, but only because we planned for it. First, we promote the read replica that's been waiting patiently in our DR region. Boom, it's now a standalone primary instance. Second, we got to update our app's connections. Usually, this is something like changing a DNS record to point to the new database's IP, or maybe updating connection strings you've stored in Secret Manager. And finally, we run our checks to make sure the data integrity is solid. And just like that, database is back online. Check. All right, next up on the list is our file store instance. Think of this as a managed NFS share. A lot of our application servers really depend on it for shared config files, user assets, you name it. It absolutely has to be available for our application VMs to work right. Now, unlike the live replica we had for Cloud SQL, our strategy for file store is all about backups. So, step 1, we identify the latest good backup. Then, over in our DR region, we spin up a brand new file store instance directly from that backup. Once it's up and running, we tell our application VMs to mount this new share, and then we just validate they can read and write files. Easy peasy. File share is back. Check. Okay, the final piece of our recovery puzzle is the data lake, which, for us, lives in cloud storage. Now, this is the big one. It holds terabytes, maybe even petabytes of raw data, analytics, archives, the whole shebang. And while it might not be as immediately critical as the database, if it's down for too long, it can totally halt business intelligence and a bunch of other key processes. And this is a fantastic example of the kind of options GCP gives you. For most situations, a dual region bucket is absolutely perfect. It automatically and asynchronously replicates your data between two regions, which gets you an RPO of about 15 minutes. Not bad at all. But for those extreme, super low latency needs, you could even use turbo replication and get that RPO down to mere seconds. Pretty cool, right? For our scenario, our dual region setup means our data is already there, just waiting for us in the DR region. There's no restore action needed, it's just there. So, we did it. We recovered all our services. High fives all around, but honestly, the most important part of this entire explainer isn't what we just did, it's why it actually worked. And the reason is simple. It worked because of what we did months ago. We tested our plan. I really want you to let this next one sink in. An untested backup, an untested DR plan, it's not a plan at all. It's just a hope. It's nothing more than a collection of assumptions that you're praying are correct when everything is literally on fire. And what do you find when you actually test? Oh, you find all the gaps, the little gotchas that look perfect on paper but just fail spectacularly in the real world. Maybe the service account in your DR project doesn't have permission to decrypt a backup. Or maybe there's a firewall rule blocking access from your failover app servers. Or, and this is a classic, the secret key you need to connect to the new database was never replicated to the DR region. Testing finds these killer problems before the disaster does. The best way to think about it is like a fire drill. You don't wait for an actual fire to figure out where the exits are, right? You practice, you build that muscle memory, and you find out which doorways are blocked ahead of time. A DR test is exactly that. It's a fire drill for your cloud infrastructure. It's what turns sheer panic into a calm, methodical procedure. Okay, so theory is great, but let's get practical. How can you, right now, start building that muscle memory? Let's walk through a simple and, more importantly, safe framework for your very first GCP DR test. First, and this is non-negotiable, create an isolated test project. You do not want to mess with production. Next, just pick one service to start. Don't try to boil the ocean. Say your database, and try a full restore from its backup or replica. Step 3, and this is key, actually validate it. Don't just assume it worked. Try to connect to it, run a few queries, make sure the data is there and looks right. Fourth, and please don't skip this, document everything. How long did it take? What were the exact commands you ran? What went wrong? And finally, step 5, tear it all down. Then, armed with everything you just learned, you improve your process and you do it all again next quarter. So, I'm going to leave you with this one question. Take a hard look at your own disaster recovery documents. After everything we've just talked about, would you say you have a genuine, tested strategy? Or are you really just holding on to a wish? Because the time to find out is now. Not at 3 in the morning when the alarms are going off.